Greetings. Here we are today, and I need you to do me a favor. Look at this line, okay? Not a line, but let's consider it like a thick line, okay? I'm talking about this part, this part, okay? And there's a reason for that, because you could see, okay, you know, this shape, not a line, but like a rectangle, okay? You have points where it's black, some points where it's white, and some points where gray, and you might say, okay, this is a two-dimensional object, you know, because you don't have depth, you just have height and width. But, well, interestingly, you might also think of this as a one-dimensional object, because you might say we don't have height, you know, how big our units are. I guess there's no such thing as not having height. In a situation like this, which is kind of weird because this doesn't have depth. This does not have depth. In this angle, it does not have depth. But in reality, it does. But we're ignoring that for now. Okay. So this does not have depth, okay, I guess, in this angle. In this theoretical perspective of a theoretical in this perspective of a theoretical object, okay, it does not have a depth, it only has a height and a width, okay, let's just say it has height and width, there's enough units for that. But I just think it's interesting that we could define if each, you know, square was a unit, then you could just define it as the number of squares and counting from one side to the other. So we just continue on, like this line, or no, not this line. Let's say this line, okay? It'll just, starting from there, it'll just continue on, you know? That's all it will do in this one direction. If you wanted, that's all it ever does. It's redundant to even consider the height dimension, because it's not changing. Oh my. It's not changing in that dimension, okay? So thus, you might not even say it has that dimension, because it's not changing. Think about the universe, I mean, any place, any dimension that's not changing, is it even a dimension? The space, there's a lot of space in here, and a lot of air. If the particles all vibrated at the same frequency, you might not even think that temperature could be a dimension. That might seem crazy. But it is, because there's, you know, this is much colder, kind of, than this, or at least it feels that way. Which is... So yeah, it's just strange in that way. But yeah. So over here, though, I'm going to thus say that this only has one dimension, width. But that'd be making a fallacy, because if I were to compare that with this line, well, maybe I could compare their heights. Technically, this is a lot thinner than this one in height, you know, a lot less height. So even though this is always staying the same, it's always maintaining constancy in that dimension. If you compare it to that one, you would be like, yeah, no, that dimension's completely different, thus must be considered. And thus, this is a two-dimensional object. I just think it's quite interesting. Wow. Hope that gives you something to think about. Please pause the video and leave if you feel this gave you enough to think about. And just think, see ya. But if you're gonna stick around, actually no, don't. Just please think.